Alright, so polynomial functions are going to give us just some examples of several of them that we could have here. I'm going to make a column that has degree and then a column that has the type of function that it is. And then I'll give us an example. Okay, what we know there, degree means the highest power in the function. So if we have a degree of 0, anything to the 0 power means 1, so that means that there is no variable at all, which means that that is called a constant function. An example of that would be f of x is equal to negative 14. There's no variable in there at all. Okay, if I had a degree of 1, that means I am linear. An example of that would be f of x is equal to 5x minus 7. Okay, know what I'm talking about on degree here. This 5x is an x to the first power, so that's why the degree is 1. It's always, the degree is always the highest power on your variables. So degree of 2, this is what we've been doing most recently, is a quadratic. An example of that would be f of x is equal to 2x squared plus x minus 9. Squared's my highest power, 2's the degree. Okay, we'll go a couple more. Degree of 3, that's called cubic. Example of that, f of x is equal to x cubed minus x squared plus 3x. We'll go one more for today. Give a degree of 4. That's called quartic. Q-U-A-R-T-I-C. F of x would be x to the 4th plus 2x minus 1. We're going to graph these things, yeah. That's easy. Alright, so.
Give me a minute, please.
Yes, gotcha. I'll leave there a second.
Probably roll it up. You roll something, that's all.
Alright, so what I got here, this says f of x is equal to negative 2x cubed plus 5x plus 8. Our directions say to decide whether or not this is a polynomial function. If it is, write it in standard form, state its degree and its leading coefficient. Alright, so all of those examples that you just copied down were all polynomial functions. Something that was in common about all of those is that their exponents were all positive. Okay, they all had positive exponents on them. That's one thing that's going to be key. So looking at this one, of that negative 2x is to the third, that's a positive 3. That 5x is to the first, that's a positive 1. Did you have an example in that list that we copied down that looked anything like this? Yeah, just normal old polynomial function. So yes, my first answer is it's a polynomial function, yes. Second answer, it said to write it in standard form. Standard form of a polynomial function starts with the highest power and they go in descending order. So this one already is. Because this is a 3, this is a 1, and this is a nothing. So those are already in descending order. Okay? If they're not, we would put them that way. So it's already in standard form. Question number 3 I asked you for was to tell the degree. What's the highest power in this? So it's got a degree of 3. And then the last thing I asked you for was the leading coefficient. Leading coefficient, C-O-F-E-F-F-I-C-I-E-N-T. Leading coefficient is the coefficient that corresponds with your degree. So if my degree is 3, that means I'm looking at this first term. What is the coefficient of that term? Coefficient means number out in front.
-2.
-2. So that's it. We answered everything they asked us to. Okay, so that the question said decide whether it was a polynomial function, and that one was. So let me show you one where you'll know where it's not. Okay. Oops, thought I hit a new page. Oh, I'm frozen up again. Come on, don't freeze up. This thing is becoming useless. Directions are the same. Decide whether or not it's a polynomial function. If so, write it in standard form, state its degree and its leading coefficient. Okay, so I told you that this one was not. So this is not a polynomial function. Reason is what Trevor just said. Because of the negative exponent. Okay.
That's the only thing. Mess it up.
Other thing, I'm going to show you one more. Another one that's not a polynomial. This one says k of x is equal to x squared plus 3 to the x. Okay. This one is also not a polynomial function. Reason is because it has an exponent that's a variable. Okay?
What time does the game start?
4:30.
Think basketball practice? Y'all get ready to go? 4.
Probably a little bit sooner than that. Alright, now the fun stuff happens on this next type of problem. I got f of x is equal to 2x to the 4th minus 8x squared plus 5x minus 7. The question says to evaluate that function when x is equal to 3.
Now you just plug in 3 for all the names.
Trevor's correct. Everybody see that? It says to evaluate when x equals 3. So we're just going to take a 3, plug it in for all the x's, and solve. So I'm going to have 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. Okay. 3 times 3 is 9 times 3 is 27 times 3 is 81. 81 times 2 is 162. 3 squared is 9 times 8 is 72. 5 times 3 is 15 minus 7. 9. $75 minus 7, 98. Where did I go wrong?
Shouldn't it be a plus?
Plus, yes, thank you. So that's 105 minus 7, which Trevor is correct, is 98. Alright, now to start thinking about graph stuff on this, and we're going to make a little chart of what some potential graphs of these different functions could look like. Buddy, got what we need there? Alright, I'm going to make a big T-chart here to make my graph.
A T-chart.
Alright, so in my top left up there, we're going to say our degree is odd, and our leading coefficient, LC is going to stand for leading coefficient, is positive. Alright, degree that's odd, that means it could be something my highest power is 1, my highest power is 3, my highest power is 5, 7, 9, so on. Okay? My leading coefficient is a positive number, so anything that's not negative would work there. What that graph is going to look like, just an example of it, if my degree is odd, any time on any graph your degree is odd, the ends of your graph are going to go in opposite directions. So one end's going to be going down, one end's going to be going up.
So that one more
Okay? When the degree is odd, the ends of your graphs are going to be going in opposite directions. So I could have a graph that looks like that, because this end's going down and that end's going up. Okay? Now the other thing that I wrote, the leading coefficient's positive, that means reading this graph left to right, it's going to finish going up. It goes up, reading left to right. That's what makes the leading coefficient be positive, tells you. Now, end behavior. When you're asked about end behavior, that means what it's doing is it keeps going forever. Okay, so f of x, which we know is the same as y, f of x is going to keep going to, on this end over here, is going to keep going down, which would be negative infinity. X on this section over here keeps going to the left, which would be negative infinity. But on this side, what does the f of x do? What does y do? It's going where?
Up.
Which is positive infinity. And what's the x do? It's going to the right, which is positive infinity. Okay, there's nothing real deep on that. Okay, we're going to stick with odds. So over here we're going to make one with our degree is also odd. But this time our leading coefficient is going to be negative. Okay, degree odd means our ends have to be going in different directions again, but the leading coefficient's negative, which means our thing's going to go downhill first. So it could look like that. Okay, so our end behaviors on this thing, here it's going up. So f of x is going higher, which is positive infinity. But it's going left on the x's, so it's approaching negative infinity. Over here my y is going down, so f of x is approaching negative infinity. But my x's are going to the right, which is positive, so it approaches positive infinity. An arrow, these are arrows, I should have written them over here, that reads approaches. It's what those, that looks like a -7 kind of, those are arrows.
Oh, I was like,
Yeah. Sure you got all that? No.
in my brain.
No. Okay, so we got our odd degrees on the top two. We're going to go even degrees on the bottom. Which means my highest power could be a 2, a 4, a 6, an 8, anything like that. We'll do our leading coefficient positive first.
Very much use flip-flop.
Yes. Alright, when our degree's even, think about what we just did with quadratics all along. That's a second power. That's a degree that's even. The ends on our parabolas always either went up or down. They went the same direction, right? So if it's an even degree, our ends are always going to go the same direction. If it's a leading coefficient that's positive, it's going to open up. So I could say it could look something like that. Okay, because both of them are going up. Same direction. Leading coefficient's positive, so it points up. Alright, so over here on my end behavior, on this side, I'm going to like draw an arrow down here. On this side, my y's, my f of x's are going up, so they're approaching positive infinity. My x's, this thing's going to keep getting wider and wider and wider to the left, which is negative infinity. Okay, this side, my f of x's are still going up, which is positive infinity. But my x's are going to the right, which is also positive infinity.
Is that an arrow on that X right there?
Yes.
Oh.
Yes. Alright, then the last one will have another even degree. But our leading coefficient will be negative. The degree is even, but our leading coefficient will be negative. So leading coefficient was positive, it opened up. Leading coefficient is negative, it's going to open down. So they'll be going the same direction, down. Something like that. Okay, so our end behaviors, f of x is going down forever here, which will be negative infinity, and the x's are going to the left, which would be negative infinity. Y's here, f of x's are still going down, which would be negative infinity, but the x's are going to the right, which would be positive infinity. So you can have an idea of the shape of any graph based on its highest power and its leading coefficient. The more bumps it's going to have in it, those are technically called turns. The more turns it's going to have in it, the higher the power. Like squared is just a parabola. It has one turn. Fourth, this would be a fourth. It's going to turn a couple of times. Sixth, it's going to turn several times.
Is there like a certain place you have to put it? Or you just...
Yeah, we'll have to plug in points and get it exact when we start graphing them, but yeah, it's not too bad.
It's
It's not.
I mean, everything else is easy. When we start graphing stuff.
Just lose it and win.
Yeah, you
Alright, so everybody got what we need here? I'm going to give us one to try out.
Oh, here we go.
I got f of x is equal to negative 0.5 x to the fourth plus 2.5x squared plus x minus 1. Directions for this say to describe the end behavior of the graph. Describe the end behavior of the graph. So first thing I need to know, well, I need to know two things. First thing is the degree. What's my degree here?
4.
The degree is 4,
Yeah.
which is an even number. Right?
Yeah.
What's my leading coefficient?
0.5. No.
Negative 0.5, which is
I was
a
close.
negative number. So you're going to your section where we have an even degree with a negative leading coefficient. Even degree means they're going to open in the same direction. Negative coefficient means it's going to be down. So this is going to be some graph that looks like that. That tells me all I need to know about the end behavior. As f of x approaches, this is going down forever, negative infinity. x is also approaching negative infinity. That's on this side, right? This is straight off your chart. But then when I move to this side, as f of x approaches negative infinity, right here, keeps going to the right, x approaches positive infinity. So there are my answers for describing the end behavior. Once you're able to get in the right section of your chart, you had that written down.
Attention students, anyone who has not returned the flu shot form, please bring it to the office now.
Oh crap, those are due today.
Thursday, I think.
I didn't agree.
Ain't nobody getting a flu shot.
Okay, well I need to fill that out.
You do?
I didn't even know.
Give me one more minute, go try.
I know.
You do right now?
Oh my
So you need to go home and you got the flu.
I can't do all of this. I won't be sure I can do it. Okay, I can do it. No.
He said that was flu.
I'm getting blood.
Yeah. Clinic code. What
In
is
the Tamiflu,
Tamiflu is what they'll prescribe if you get the flu.
I swear I did.
When, this weekend?
Are you done, Herbert?
The flu can be out any time of the year, buddy. He may have had the flu. Cut him a break.
I got it one time when I was before that.
Is it month, midday?
Alright, we got f of x is equal to x cubed plus plus x squared minus 4x plus 2. Direction, state of graph. Okay, direction, state of graph. Alright, I want to get an idea in my head of what this thing's going to look like before I start. What's my degree?
3.
3, which is odd, which means the ends are going to go in opposite directions. In my little pea brain, these are like snake graphs, lightning bolt graphs. That's what I think of. Now, since my leading coefficient is positive 1, right? That means it's going to climb uphill first, left to right. So I know, just follow my trace here, I know that this would look something like that. I just got to get some specific points now.
Can
Okay?
you plug a number
So
in?
I can pick x's and plug them in and solve. Very
0.
good. All right. Trevor wants to check 0. So I'm going to make me an XY input-output table. 0 is an easy one. Because everywhere there's an x, if you put a 0 in, that turns to 0. So you've got 0, 0, 0. All that's left is a 2. So we're going to have a point at 0, 2. Okay, I don't know how big this is going to be, so I'm going to count on every line. Make sure I got enough room. Okay, I need another point.
1.
Okay, let's plug a 1 in. That's 1 plus 1 minus 4 plus 2. That's 0, isn't it?
Yep. Plug in 2 now.
Okay, y'all letting Trevor pick all our points. 2 cubed is 8. 2 squared is 4. 4 times 2 is 8. 12 minus 8 is 4, so that would be 6.
How many points per need? 4?
1, 2, 3, 4, 5, 6. Alright, so we can see where it turns up, right? I need something over here. So we need to pick some negative.
-1.
-1. So that's -1 plus -1 squared is 1. -4 times -1 is a positive 4. So that's 0. 4 plus 2 is 6.
-1. 6.
Okay, but remember it starts, it's got to be going uphill at some point, so I need to go even smaller than -1. I need to see something over here.
-0.5.
That's not smaller than -1. -3.
Oh, that's
-3 cubed is -27. -3 squared is 9. -4 times -3 is 12. So it's negative 18. This is supposed to be 12. So let's do that. Negative 15 plus 9 is 24. 26. Did y'all get 26 on that? Negative 27 plus 9 plus 12 plus 2.
26, yeah. 26.
But I'm waiting on
Oh.
it. Negative 27 plus 9 plus 12 plus 2.
What number?
Negative
3.
Say that again, Molly. Negative 20. Negative 14. Negative 27 plus 9 plus 12 plus 2, Trevor.
Negative 27 plus 9 plus 2.
Plus
Negative
12.
Plus.
Got negative 4.
Yeah, that's what
We're losing.
Plus 12 plus 2.
Negative 4.
Oh, I thought
Negative
you were
4.
saying, sorry.
That's okay.
It's negative 4.
Yes,
Alright.
it is.
So left 3, down 4. Alright, so visualizing the points that we have there, I can see it goes up, turns, and then goes back up.
This is
So
all
we got
over
a
the
pretty
place.
good representation of that graph.
That's an N.
Okay? Now, on your calculator, I want you to graph it in the calculator and see if it looks similar to the picture your calculator shows. So hit Y equals on the very top, right underneath the screen, very top left, right underneath the screen, hit Y equals,
And then plug those
and then
numbers.
just type this in. You know where the X button is? It's right below mode. That's got an X, a T, a theta, and an N. And then to get the third power, your power button is the caret, the rooftop. Anybody need help typing it in? Let me help you. Holler at me.
Alright, 2 plus 3.
Just type that whole string in.
And you do.
What you do now?
Then hit graph from the very top right.
Get out of here with that.
No, so we can just type this in.
Yeah, we could just cheat. Type it in. It's not cheating because you let
Now, anybody else need help getting it typed in? What you need to do from there is be able to produce some of these points. But guess what? They're in your calculator also. So hit second table, which is the graph button. Hit second table, and it'll give you any point that you want.
Hang on, so that's, you put Y equals, plug it in.
On the graph button, so second graph.
Plug in this.
You can scroll, you can check our points, and just go over there and find any points that you want.
Then second.
You right now have to do this.
Yeah, so I don't forget on the test. I had, on my 3 tests, it was all like work on the calculator. And I wasn't here for like 5 days. But I had all the stuff, how to plug it into a calculator.
Whoa.
So what do you have to get it all? You know
Oh,
those
that's
3-step
just how you
equations?
get points out of your
On
table.
the calculator.
So those are all the X's that, no, you can't change them. Those go with that graph. So you could check ours, like we had 0, 2. Yep, 0, 2. That one we fought over was negative 3. So scroll, put it over here on the X's. Scroll up to negative 3 and see negative 3.
Second table.
Forgot
So you wouldn't have to do all that work.
No, it didn't look. Is there a way?
I was like, okay.
No,
Why?
because those, I mean, it's like the work that we did. That's for every graph, they're going to be specific to that graph.
You're not?
Very top.
Well,
Okay.
huh?
Exponent.
Oh.
Right underneath here. Third.
We're doing it on.
I was like, God. I was trying to get the box.
Huh?
No. And
Goofy.
Plus 2.
Oh.
It's a little backup pouch right here.
Graph. I'll show you a picture.
No, he's not. He ain't getting no.
If you want to get points on that table, you would
I
get
think
7.
300 just like that.
How long is it?
Any point on there you want.
I don't-
Scroll up and down the X's.
Ah.
long enough. Let me see that. Go.
Alright, so let's see now, since you know all the tricks, if you can get a graph of f of x is negative x to the 4th minus x cubed plus 2x squared minus x minus 3. Okay? Need a graph of that. I need you to tell me at least 4 points. Okay? You can do it by hand or the calculator, either one.
Do you have anyone that does it on the hand?
Me.
Except old school.
Give you 4 points.
3.
Yep.
4.
4.
Do we need to draw that graph for
Yep.
you? Huh?
Yep.
Alrighty.
Nards.
Nord.
I need one.
Second table.
X
0, negative 3, 1. What'd you get? 1 negative 8?
Did you get that? How did you not get that?
What's your graph? No, mine look like that. What's yours look like?
Go look on the table.
What's your graph look like?
I didn't first graph yet.
I think I might have topped it in though.
Oh.
How do you go back to your graph?
Hit graph.
How do I go back to what I'm plugging in?
Hit y equals.
Alright, negative x4, negative x3, plus 2x squared, minus x,
Awesome. Oh.
minus x,
second and table it.
minus 3. That's what mine looks like. I got it.
Second in the graph button.
I was just making sure I topped it in. I did though. I did. Yeah, I got this thing looking
Did y'all get that?
No, that's
No,
right.
it
Go to
It's wrong?
No, you're
Hit y equals and switch top to. It's a plus 2x squared.
Oh, boy.
So am I freaking stuff wrong, dude?
Yeah, that'll change your points, yeah.
God.
What'd you say?
I hate my life. Too much stuff.
Oh.
Oh my gosh.
Which key was it? Which key was it?
There's no way.
Hmm? Thank you, buddy. Thank you. You know what I'm talking about?
Alright, Jody, tell me one of your points.
0, negative 3.
0, negative 3.
I got that.
My turn?
Sure.
Alright, Connor, tell me one of your points.
-1, 0.
Negative 1, 0. Steven, tell me a point.
1, negative 4.
1, negative 4. Chrislyn, tell me a point.
Negative 2, negative 1.
Negative 2, negative 1. Trevor, give me a point.
2, negative 21.
I don't want that one.
1, negative, you already got that.
Hey,
Do 1, negative
3,
You have
negative 3, negative 36.
I don't want that one.
0, negative 3.
You're out of luck.
Is that all we got?
Yeah.
Okay, notice the ones I was telling them I didn't want. I don't want to count to 20 or 30. I mean, I'm not going to do that.
Integrals.
Okay, so looking to connect these now. On your picture of your graph, did it turn on that point?
Yeah.
Yes, it did.
It did?
No.
No,
Yeah.
I think it goes up a little bit above that,
Mine
doesn't
went
it?
up.
Yeah,
and came
should
back
go
down
up.
and turned a little bit more.
Look, something like that over there. Is that
Connor
kind
is
of that
Casper.
side of it?
Yeah.
And then it kind of snaked a little bit right there.
Yeah. Of course, I am.
Yeah. Y'all get something similar to that? Hello?
Yes,
All right, everybody okay on that?
You try another.
Oh,
All right, I'm going to hit the button in just a second, and you'll have an exit question pop up. Give me a minute to get that going.